The topic of my case study is the Daphne Cockwell Health Sciences Complex, Toronto Metropolitan University, located at Toronto Metropolitan University, Toronto, Canada. The vernacular architecture style of Canada consists of houses, huts, barns constructed of mud, straw, thatched roof with a distinctive steel roof. The styles are further classified as Prairie Vernacular, West Coast Vernacular, Quebec Vernacular, and Ontario Vernacular. Some other styles include log cabin houses and bay and gable houses from the 19th century. Timeline starts in early 17th century with French settlement, then British settlement in 1760s, log and cabin structure in 1780s with Georgian-style houses, then the development of city of Toronto in 1834 with in mid-19th century industrial architecture came in action. Then in 1948, Ryerson University started, and in late 1970s, deindustrialization began, and in 2020, Ryerson University's campus development plan came in action. Project details for Ryerson University DCC centers are architecture done by Perkins and Wills, owner Ryerson University. Project site previously was a brownfield site, a parking lot. Site area is 28,234 square feet. Total area 270,000 square feet, 28 floors in total with 345 feet tall building. Since 2008, Ryerson University enrollment has grown over 50%, resulting in the need of better infrastructure. The campus master plan from 2020 to 2030 is to develop more infrastructure facilities. From 1950 to 2020, the growth in the campus can be seen in this chart below. By bringing in a unique hybrid development without disturbing the urban environment of the site, allowing transparency in high-density zone with easy public accessibility and interactive indoors environment, DCC was designed by Perkins and Wills in 2015 as a part of the campus master plan. The site was an open parking lot turned into 28-story vertical campus featuring 8 lower levels for academics, administrative, and research department, while the upper levels are for the residential purpose of the students. The concept of vertical campus designed to celebrate density, urbanity, health, inclusion, and sustainability. The concept party diagram showing the podium and the tower with lifting to open the ground floor to bring the transparency in the urban fabric and to separate and create a public area with massing to create an engagement in the tower. The party diagram showing the placement of each floor, the ground floor, the podium level, and the tower, with the level 1 having the main entrance, and then level 2 having classrooms, level 3 having occupational and public spaces, level 4 for the nursing labs, and basement 1 is for the fabrication zone. Level 5 is the School of Nursing Facilities and Research. Level 6 is the School of Nutrition and Midwifery. Level 7 is for the administration of the university, and level 8 is the green rooftop and the residency access with the typical layout for the residential tower. Section showing the inside functions of the building and some pictures showing the interaction of its occupants with a cooking lab for the nutrition department and the green rooftop. Climate zone is the area which is warm, summer, humid, continental. The temperature range shows that from June to September, the temperature can go above the comfort zone, which is 5 to 10 degrees Fahrenheit, which is not that higher, but still requires some cooling inside the building. And from the month of October to April, the temperature is around or below 20 degrees Fahrenheit, which requires some heating inside the building when it reaches -2 to -5 degrees Fahrenheit. The sun shading chart shows the red color to the yellow color shows the heat and the blue color shows the cold. In summers, from the month of June to December, from 10 a.m. to 5:30 p.m., sun shading is required. The wind velocity is high in the month of March to December with 22 mph in March and lowest in August, and throughout the year it's around 10 mph. Wind direction is from north-northwest to south-southeast. Some design inputs after considering the climatic data are fast ventilation, daylighting, direct gain from glazing and heat storage, green roof, and east to west form of daylighting. Apart from that, major windows are facing the east and west direction to efficient daylight saving. The design was considered with innovative approach, high efficiency building system for sustainability, focus on health and well-being of the occupants, and high accessibility for disabled. 3 months in pre-design study stage with 200 stakeholders to understand the current city needs and the public and private vertical campus relation, leaving a social impact with mental restoration, physical activity, social connection, and cultural understanding. Environmental impact of biodiversity, habitat conservation, bird safety, flora and fauna by the green roof on the level 8 floor, having utilities made of high efficiency material, chilling being technology used for heating and cooling with energy recovery ventilation to minimize the energy usage. The building includes 33.78% recycled materials and 56% of the materials were manufactured locally, such as concrete, steel, aluminium. A total of 4,867 metric tons of waste was hauled off the site, from which 3,694 was done in landfill and incinerated, resulting in 76% waste diverted. Around 67% of the rainwater is managed on the site, while the rainwater collected annually is 369,863 liters. The percentage of potable water reduction through efficiency measure is 65%. Overall, the building is using 42% less energy than the baseline building, reducing greenhouse gas emissions by 645,000 kilo annually, reducing the heating and cooling load in the building. The DCC complex is a well implemented example of vertical campus which reimages and addresses the current urban density and sustainability challenges. The building is a living lab, helps in teaching occupants and operators how to improve the building performance by sharing the collected data with the building occupants to bring awareness and sustainability.